In the first part of this lesson, we discussed the center of mass of a system of objects. We also discussed if there are two moving objects. Well, we will reduce it to two moving objects. If there are two moving objects, how does the center of mass of the two object system move? Do you remember how to find the velocity of the center of mass? If I have one object of mass m1 moving with velocity v1, another of mass m2 moving with velocity v2, their center of mass will be moving with a velocity given by m1 v1 plus m2 v2 divided by m1 plus m2. In this part of the lesson, we will look at center of mass as a reference frame. What does that mean, center of mass as a reference frame? If you go and stand on the center of mass of these two moving objects and measure the velocities of these objects from the center of mass, then you are using the center of mass as the reference frame. In other words, you need to find the velocity of the first object with respect to the center of mass. Now, you remember we found the velocity of one object relative to the other. In other words, we are now going to find the velocity of each of these objects relative to the motion of the center of mass. Now, do you remember what we did to find the velocity of A relative to B? Now, this time our B is the center of mass. So, to find the velocity of A relative to B, the center of mass, we bring B to rest. Is that right? Apply an equal and opposite velocity so that the center of mass will be at rest. Then apply the same velocity, equal and opposite velocity of the center of mass to both the objects. And the resultant of those velocities, you can now see the object 1 has a velocity v1, object 2 has a velocity v2, and the velocity of the center of mass we call v center of mass. Now what do? We apply an equal and opposite velocity of the center of mass to all the objects in the system. So what will be the velocity of this object? It will be v1 minus v center of mass. So when you look at the object from the center of mass, its velocity will be v1 minus v center of mass, and the velocity of this object when observed from the center of mass will be v2 minus v center of mass. Alright, so we are now going to find the velocities of the individual objects in the system measured from the center of mass reference frame. In other words, we are going to use the center of mass as the reference frame for measuring velocities and momentum of the objects that make up the system. Alright. To understand the concept of the center of mass reference frame, let us consider a truck and a car that actually we talked about in our previous examples in the first part of the lesson. Now, the car is moving west at 20 meters per second. That means v1 equal to negative 20 meters per second I. This is the same example we did in part 1 of this lesson. And the truck is moving east at 16 miles per hour. Now we found the center of mass of this. What is the velocity of the center of mass of these two objects? we observed and we found that the velocity of the center of mass is 4 meters per second east. If you don't remember it, you can calculate that. Velocity of the center of mass will be m1 v1 plus m2 v2 divided by m1 plus m2. So its center of mass is this. It is moving east at 4 meters per second. So we are now going to observe from the center of mass. We are going to use the center of mass as the reference frame. So if you now stand on the center of mass, you will be moving at 4 meters per second east. You are now at the center of mass reference frame. Now, you are moving east at 4 meters per second, and you are going to measure the velocities of the truck and the car from the center of mass reference frame. Alright, here, this is the person standing there and taking the measurement. What do? We bring the center of mass, to rest. Doing what? Apply an equal and opposite velocity. So bring the center of mass to rest by applying an equal and opposite velocity, which will be negative 4 meters per second. That means I need to do that for all the objects in the system. I apply a velocity negative 4 meters per second. To take the measurements from the center of mass reference frame, we need to find the velocities of the car and the truck relative to the center of mass. So bring the center of mass to rest by applying an opposite velocity to that. So the center of mass is now at rest. And now, when the center of mass is at rest, what is the velocity of the car? It is now negative 20 minus 4, which is negative 24 meters per second. When you observe from the center of mass, the car will appear to be going west at 24 meters per second. What is the velocity of the truck relative to the center of mass? It will be 16 minus 4, that will be 12 meters per second east. Okay, let's write that down. Now, what will be the velocity of the car if you measure it from the center of mass reference frame? What will be that? If u1 is the velocity of the car measured from the center of mass, then u1 will be equal to v1 minus v center of mass, because we have brought the center of mass to rest by applying a velocity minus 4 meters per second, and we need to apply that to both the objects. So u1, what does u1 stands for? u1 is the velocity of the car measured from the center of mass reference frame. So u1 equal to v1 minus 4v center of mass, and that will be u1 equal to negative 20 meters per second I minus 4 meters per second I, that is negative 24 meters per second I. When you measure from the center of mass, the car will appear to go west at 24 meters per second. That's the meaning there. Alright, what is the velocity of the truck relative to the center of mass? Alright, what will be the velocity of the truck measured from the center of mass? If u2 is the velocity of the truck measured from the center of mass, that u2 will be v2 minus v center of mass. v2 is 16 meters per second I minus 4 meters per second I, that is 12 meters per second I. That means when you measure the velocity of the truck from the center of mass reference frame, the truck will appear to go east at 12 meters per second. Now tell me, what is the total momentum of the system measured from the center of mass reference frame? The total momentum of the system measured from the center of mass reference frame. Let's calculate the total momentum. The momentum of the car in the center of mass reference frame. Now remember, the velocity of the car in the center of mass reference frame is m1 u1, where u1 is negative 24 meter per second. P1 center of mass, the momentum of the first object in the center of mass reference frame is m1 u1, which is 1500 times negative 24. That is negative 36,000 kilogram meter per second I. What is the momentum of the truck in the center of mass reference frame? P2 center of mass is M2 U2. Now you remember the truck is 3 metric tons, 3,000 kilogram. Its velocity is 12 meter per second I, and therefore its momentum is 36,000 kilogram meter per second I. What is the total momentum of the system measured from the center of mass? It will be negative 36,000 plus 36,000, which is 0. That means if you now have a system of objects that are in motion, if you now measure the velocities of all the objects in that system from the center of mass reference frame and calculate the momentum of all the objects, the total momentum of the objects calculated from the center of mass reference frame will be 0. And therefore, the center of mass reference frame is also called zero momentum reference frame. Why is the center of mass reference frame called the zero momentum reference frame? Because the total momentum of all the objects measured from the center of mass reference frame will be 0. Okay, let's do a problem to consolidate what we discussed so far. A 3 kilogram object is traveling to the right at 5 meters per second. Traveling to the right at 5 meters per second, the velocity is positive. And a second 3 kilogram object is traveling to the left at 2 meters per second. Traveling to the left, the velocity is negative. Always identify the direction and associate the sign positive or negative. A. Find the total kinetic energy of the two blocks in this reference frame. In what reference frame are these velocities measured? These velocities are measured in the lab reference frame where I am standing. You can see here. Let me see if I can show that to you. Now, I have two objects here. This is the first object that of 3 kilogram traveling to the right at 4 meters per second, and the second object of mass 3 kilogram traveling to the left at 2 meters per second. So the velocity of the first object is positive, the velocity of the second object is negative. Now these velocities are measured from where I stand. We call that the laboratory reference frame. Now when I measure the velocity of the first object is 4 meters per second I, that is positive. The velocity of the second car is negative 2 meters per second I. And therefore, the first question is, what is the kinetic energy of the two-car system? two object system measured from the lab reference frame? Well, that's simple. It will be 1/2 m1 v1 squared plus 1/2 m2 v2 squared. Okay. Alright. B, find the velocity of the center of mass of the two-body system. You know how to do that. C, find the kinetic energy of the center of mass. Kinetic energy of the center of mass. What is the mass of the center of mass? The mass of the center of mass is m1 plus m2. And the center of mass is moving with a velocity v center of mass. So you can calculate the kinetic energy of the center of mass. Find the velocities of the two objects relative to the center of mass. Well, you know how to do that. E, find the kinetic energy of motion of the two blocks relative to the center of mass. Find the kinetic energy of the two objects as is measured from the center of mass. Show that your answer in E added to your answer in C equal to your answer in A. In other words, you got to show that the kinetic energy of the two objects measured from the laboratory frame equal to kinetic energy of the center of mass plus the kinetic energy of the two objects measured from the center of mass. That is the question. Alright, let's look at the data. M1 equal to 3 kilogram, V1 equal to 5 meter per second I, M2 equal to 3 kilogram, V2 equal to -2 meter per second I. Moving to the left. So in A, the kinetic energy of these two objects measured from the lab reference frame is 1/2 m1 v1 squared plus 1/2 m2 v2 squared. Use all the given values and that gives you 43.5 joules. So this 43.5 joules is the kinetic energy of the two objects measured from the laboratory reference frame. Alright, would you remember this value? We need to remember this because to do the last part. B, what is the central velocity of the center of mass? The velocity of the center of mass is m1 v1 plus m2 v2 divided by m1 plus m2. Again, use the values. m1 v1 is 3 times 5 plus m2 v2 is 3 times -2 divided by 3 plus 3. And that will be, what does that give you? That will be 15 minus 6. 15 minus 6 is 9. Is that 9? 9 divided by 6, which is 3/2 meter per second. The velocity of the center of mass is 3/2 meter per second. We answered part B. C, find the kinetic energy of the center of mass. Well, we know the velocity of the center of mass. We know the mass of the center of mass. That would be m1 plus m2. So, let's now find the kinetic energy of the center of mass. Kinetic energy of the center of mass is 1/2 m1 plus m2 v center of mass squared. And that will be 1/2, 3 plus 3. The velocity of the center of mass is 3/2. So 1/2 total mass times velocity of the center of mass squared. That gives you 27/4 joules. Alright, we now need to find the velocity of the two objects relative to the center of mass. In other words, measured from the center of mass. Let's call these velocities be u1 and u2. u1 is the velocity of the first object relative to the center of mass. What will u1 then be? u1 will be v1 minus v center of mass. u1 is v1 minus v center of mass. That is 5 minus 3 over 2, and that is 7 over 2 meter per second. What is u2? The velocity of the second object relative to the center of mass. u2 is v2 minus v center of mass. v2 is negative 2 minus 3 over 2 is negative 7 over 2 meter per second. What is the kinetic energy relative to the center of mass? What is the kinetic energy of these two objects measured from the center of mass? It will be the kinetic energy of the first object measured from the center of mass will be 1/2 m1 u1 squared. The kinetic energy of the second object measured from the center of mass will be 1/2 m2 u2 squared. So K relative, what does K relative stands for? Kinetic energy measured relative to the center of mass is 1/2 m1 u1 squared plus 1/2 m2 u2 squared. Well, we know all these values. When you square the negative values, they will become positive. So all the values will be positive. 1/2 m1 u1 squared plus 1/2 m2 u2 squared. Simplify that. That will give you 147 over 4 joules. That is the kinetic energy measured from the center of mass of the two objects. And this is the kinetic energy of the center of mass. Now, what are we supposed to do? We are supposed to show that adding the kinetic energy of the center of mass to the kinetic energy of the two objects measured from the center of mass equal to the kinetic energy of the two objects that we measured from the laboratory reference frame. Now that value is 43.5. So we need to show that 27 over 4 plus 147 over 4 equal to 43.5. Is it true? Yes. 27 over 4 plus 147 over 4 is 43.5. What does that tell you? It tells you that the kinetic energy of the system of objects measured from the lab reference frame equal to the kinetic energy of the center of mass plus the kinetic energy of the objects measured relative to the center of mass. Now this is an important result. If you have a system of objects, if you measure the total kinetic energy of all those objects from the laboratory reference frame, and then measure the kinetic energies from the center of mass reference frame, the total kinetic energy measured from the lab reference frame will be equal to the kinetic energy measured from the center of mass reference frame plus the kinetic energy of the center of mass. Actually, that is not much of a difficult thing to understand. It is actually something that follows from the definition of velocity of the center of mass. Okay. Now this brings us to the end of the lesson on center of mass and center of mass reference frame. I have only done a couple of representative problems. Now you need to go and do all the homework to make sure that you understand these concepts. All right? I will see you for the next lesson in this unit later on.